7.3 solubility. So when we look at these pictures of putting this solute into the solvent, you will notice it's all dissolving. Whereas in this picture here, it's trying to show that, yes, it dissolved, but there's still plenty left over. You dumped a whole bunch of stuff in there. So we're going to look and see what those different terms mean. So solubility. It's the maximum amount of solute that dissolves in a specific amount of solvent. It is temperature sensitive for solutes. What that means is if you change the temperature, a different amount is going to dissolve. It is expressed as grams of solute in 100 grams of solvent, and that solvent is usually considered water. So we write it as grams of solute over 100 grams of water. Now, unsaturated solutions contain less than the maximum amount of solute. So that means you could dissolve more solute in an unsaturated solution. So that term unsaturated means something. As opposed to its opposite, saturated solution contains the maximum amount of solute that can dissolve. So if you put any more in, it's just going to go down to the bottom because of the fact that no more can dissolve. And so you know you have a saturated solution when you have undissolved solute at the bottom of the container. The saturated solution contains solute that does dissolve as well as solute that recrystallizes in an equilibrium process, meaning you got clumps of it down at the bottom. So let's press pause and see if you can figure out if the following solutions would be considered saturated or unsaturated. All right, you're back. So if salt disappears when it's put in water, then you know that you could still put more salt in there because you don't see any at the bottom. So that would be considered an unsaturated solution. Now B, sugar is added to a cup of water does not disappear but sits at the bottom of the cup. Well, you know that yes, sugar is going to dissolve in water, but if not all of it disappeared, that meant you had a saturated solution because you had more sugar in there than could dissolve in your water. So now then, let's put some math with this concept. So at 40 degrees Celsius, the solubility of KBr, so that means the solubility of this solute, is 100 grams per 100 grams of water. So identify the following solutions as either saturated or unsaturated and explain. Press pause and come back. All right, so we have this ratio for our solute, KBr, is 80 grams to 100 grams of water. We could think of it as a ratio. We could think of it as, okay, so 80 grams to 100 grams, that's 80%. Different ways that we can look at this. So let's look to see what they give us. So on A, 60 grams is added to 100 grams. Well, we know there that different ways to look at this, that we could still put 20 more grams in here before it is considered saturated. So that means this is unsaturated. Another way to look at it is it's only 60%, whereas up here 80% for saturation. Now B, 200 grams of KBr is added to 200 grams of water at 40 degrees. Well, the temperature hasn't changed, but this ratio of 80%, even though we look at this and it's per 200 grams of water, notice 200 grams of solute to 200 grams of water, well, that's 100%. No, you can't get 100% in there when your ratio, they already told us, is 80 over 100 or 80%. So no, that's considered a saturated solution. You're only going to get, let's see, twice as much of 80 because this is twice as much. So you would only get 160 grams to dissolve. So then let's look at this last one, C. 25 grams of KBr is added to 50 grams of water. Well, different ways that we could look at that. 25 to 50 is half of that. That is a 50%. And since this solubility is 80%, then we know that it is less than 80%, this is 50%, so we still have more room to dissolve more solute in it. So it is considered unsaturated. Now, the effect of temperature on solubility is dependent on different things. First of all, it's dependent on if you're really talking about a solid or a gas. So when we're talking about temperature changes, if we're putting solids in, you will notice that as the temperature increases, that quite often you can get more solid to dissolve. It doesn't always work that way. There are some solids that as you put it in warmer water, you're not going to get more to dissolve. Even something so simple as sodium chloride, which is usually the type of salt we're going to be putting in water, its solubility does not increase much, even though you increase the water temperature. But here's what is really weird. It's just the opposite for gases. As you increase the temperature, gas solubility decreases. And that has a lot of effect on a lot of things in nature. So let's just think about a couple of examples here. Why could a bottle of carbonated drink possibly explode when left out in the hot sun here in Arizona in your car? Let's say you put it on the back seat in the back window where you get tons and tons and tons of light shining through and it's really hot. Well, because then your drink is going to have the water become very warm and you have less gas, the CO2 that can dissolve in it, so it comes out of the solution. And we know from past experience that when something goes from the liquid state, dissolved state, into the gas state, it's going to need a whole bunch more room. And the can is then going to explode as the gas demands that it has more room. And it explodes because the CO2 gas needs more room when it goes from the liquid state to the gas state. You may have experienced this if you live in Arizona. I have. The back of my car a long time ago had a 6-pack of root beer explode in it when I left it in the sun. Well, not everybody does that. But, why do fish die in water when it's too warm? It's not that you've burned them up and roasted them. It's because you've suffocated those poor little fish. Why? Because as the temperature of the water becomes warmer, less oxygen gas can be dissolved in it. So as the temperature of the water becomes higher, less oxygen is in the water, which means there's less oxygen for the fish. And if the fish, depending on the type of fish, they need a certain amount of oxygen. So they're going to die. Think about it. Why are trout, that you go trout fishing up in the White Mountains to catch trout, why are trout for the most part not down here in the canals? Well, because the trout require more oxygen. Now you'll find carp quite often down here in the canals in the heat, but that you won't find the trout. And if the people go and stock the ponds in the winter in the Phoenix area with trout, that's great. But guess what? If the trout aren't then caught all by summertime, it's not going to have enough oxygen in the water because the water will heat up in the summertime and the trout will die. The carp won't, but the trout will. Now then, solubility and pressure. Henry's law states that the solubility of a gas in a liquid is directly related to the pressure of that gas in the liquid. So a moment ago we were talking about temperature. Now we're talking about pressure. So at higher pressures, you can get more gas molecules to dissolve in the liquid. So Henry's law has to do with pressure, whereas a moment ago we were talking about temperature. So if we increase the pressure, we can get more gas molecules to dissolve into the liquid. So how do they get all that carbonation in a can of soda pop? Well, they use CO2 gas at high pressure to get more CO2 to dissolve. So what happens when you open that can of soda? Well, you open that can up, you release the pressure that makes some of the CO2 come out. Open a can of soda, put it in a fridge, and try it the next day. Has it gone somewhat flat? Absolutely. Why? Because you released the pressure, and so the CO2 was able to come out over time. Now, when you open a can of warm soda, the results are even more pronounced. Go try it. Compare opening a warm soda to opening a cold soda. A lot more CO2 comes rushing out of the warm soda and it tastes flatter. Why? Well, because it is flatter. Not so much gas is dissolved in a warm solution than a cold solution. That's why soda pop always tastes so much better cold than warm. Now, when you're scuba diving, you're told not to go too deep because for every 10 meters, 33 feet, the pressure increases by 1 atmosphere. So then at 33 feet deep, the pressure's 2 atmospheres, and at 66 feet deep, it's 3 atmospheres. Well, after 127 feet deep, too much nitrogen gas is forced into your bloodstream, which impairs the thought process, like as if you're really drunk. So that wouldn't be good. And then when you come to the surface too rapidly, you get something called the bends. So what is that and why is that? Feel free to go look that up. But yes, so Henry's law is used in scuba diving. If you've ever done scuba diving, you need to know very much about what happens to the pressure of the gas as you go down and what happens as that gas goes into your bloodstream.